right, thank you. My pleasure to be here. So let me get going. It's a short slot here, so let me get going. The first thing I want to do is say something about this word machine learning. So I finally, after 30 or 40 years, figured out what it is, all right, and it took all this time. So I've actually never been entirely comfortable being called a machine learning researcher. I thought of myself as doing statistics and computer science and kind of blending them, and I'm trying to head both of those fields in new directions. But here's what it is. So the right metaphor is the emergence of the engineering fields back in history. So think about chemical engineering. So in the 30s, 20s, and 30s, there wasn't chemical engineering. It did not exist. There was chemistry. There was fundamental knowledge about how to put things together in test tubes. There was fluid flows and mechanics and so on. And so there was kind of enough there that people could start to sense that they could build things a little more like factories, not just in a lab, putting together small amounts of stuff. You could do it at scale, and you could do it rapidly, and you could make it economically viable. And a whole new thing was emerging called a chemical factory. And it succeeded so well that we almost forget that it kind of happened. It just now exists as part of the background of our lives. But in the 40s, people started to build these kind of things called chemical factories, and they didn't have really much idea what they were doing. They had a little basic knowledge of how to put together little small amounts of stuff and so on. I'm going to look into this a little bit more of the history, but a lot of those factories exploded. A lot of them didn't work. A lot of them hurt people and so on. And eventually they started to get it right, and an academic discipline emerged of how do you put stuff together at scale, okay? And that kind of happened in parallel. It changed our world. It made our world a better place. The materials we have, in fact, even our computers, goes back to that era. So think about electrical engineering. So before there was electrical engineering, there was already electromagnetism. There was Maxwell's equations. So in some sense, it was done. You knew everything you needed to know. But no, you had to learn how to build circuits. You had to learn how to bring power from one place to another. You had to learn how to, make a whole system, a world, planetary system that would actually work and be economically viable and wouldn't burn things down and hurt people and so on. To this day, that system is still burning things down. But nonetheless, there emerged a discipline called electrical engineering. It had its own principles. It wasn't just Maxwell's equations. There was impedances and circuit design principles and so on and so forth. Okay, so I hope you can guys see where I'm going. What's happening right now is the emergence of a new branch of engineering. Okay, but we're in the very early days of it. Okay, so the idea you can write down job descriptions and have people know what they're doing, sign them up, and kind of it all just works, and if it doesn't work, you kind of adjust a little bit, that's just wrong. Okay, we're not there yet. We're in the early days of trying to just build things in a very ad hoc manner, put together algorithms with some data, with some business model, hoping that the whole system will kind of somehow work, and we'll make money, and the economy will go forward, and we'll be all happy. All right, mostly that kind of works because people are smart, and we kind of deal with edge cases and all, but about half the time it just doesn't work. All right, and so I know that because I consult a fair amount, and I just see companies trying things out, it doesn't work, and they fail, and they die. Okay, way more than any other business model I know about. All right, also it doesn't work in the sense that we have all these little problems like robustness issues and fairness issues and privacy issues and so on and so forth. They keep coming up. Right? Why do they keep coming up? Because we haven't thought about, we don't know how to build the big systems. These are all not just their little errors. We add more data and it kind of works. No, these are conceptual, deep problems about an emerging engineering discipline. It hasn't happened yet. All right, so how do you operate in this area? You can wait 40 years, and the discipline will have emerged, and there will be easy ways to hire people with job descriptions that actually can solve the problems you want to solve. There'll still be creativity needed. Or you can be a really smart person in this era like a chemical engineering person in the 40s. All right, so I'm going to try to give a talk that aims a little bit by people like that. So I'm an academic and I work on research questions. I'll probably try to get there a little bit, but I'm not going to go through all my slides on that stuff. I'm also going to talk about business models, about kind of how do you think about structuring a business in an era where it's all kind of still being made up as we go along. Okay, and what kind of business models do we want to build? Okay, so my title has to do with just at least minimally bringing in a little bit of microeconomics into our thinking. Okay, this is not just about computer science and statisticians sitting down and writing software and about software design and systems and all that. That'll get you something, but it'll get you something probably breaks and probably doesn't make money for you. All right, so you've got to think about it as part of a bigger system. That's going to be the message throughout the talk. Microeconomics is one way to start to help you to think about a bigger system. Okay, and so you can just even having a business background, understand a little bit about supply demand and matching and scarcity and so on will help you designing actual systems that do data science. Okay, so I'm going to talk a little bit about kind of digging a little bit more deeply into what machine learning is kind of almost more technically, There's a pattern recognition side to it, where you take vast amounts of data and you try to find patterns. That's what everyone is focused on. That's what deep learning is. Okay? It's nothing but that. It's pattern recognition. That's a word from the 60s and 70s. Dude and Hart was a famous book that did it. It was gradient descent with loss functions with bags of parameters. All right, so we have much bigger of all of that. It's on steroids now, but it's just finding patterns. Finding patterns is not enough to make good decisions, okay, at all. So we're going to talk about that a little bit. All right, so I already said a little bit about what machine learning is really. So if what I'm saying is true, there should be kind of a real-world emerging discipline that looks like engineering out there. Okay, so this is not about the neural nets or the architectures or the academic research so much as it is about already there must exist factories out there. All right, and they're due, and this happened already like in the 1990s. So this is my little history of what has happened. It's different from most machine learning people's. So my version of this is that it was kind of really got started in earnest in the 1990s. A company like Amazon had large numbers of computers. It wasn't being called the cloud then, but it was large numbers of computers and large amounts of data to do things like fraud detection. You had so much data that you could start to build fraud detection. And fraud, credit card fraud, was in the 1% to 3% range. There's no way you could build an e-commerce with that kind of fraud. So they had to get the rate down to 0.001% or whatever. And they did that with the algorithms of the day, pattern recognition. Those were called random forests in the day, but who cares? It's one of these sort of algorithms. That really led to a billion-dollar industry, and I particularly want to emphasize supply chain management, kind of same ideas. You had a lot of data in the back end. You were trying to model how long it took to get ships across the ocean so you could have all your products arrive at the right place at the right time. And eventually, a company like Amazon could do that with 1 billion products and hundreds of millions of people. And so you can imagine the supply chain that needed to be worked on, and was, by hundreds of researchers building large-scale. So that led to the cloud, obviously. Okay, the cloud just didn't emerge out of somebody's thinking. It emerged because these people built it already, and it was sitting there inside of places like Amazon. All right, I think in the second generation, that was what I would call the human side. That realizing that they had all this data and all these compute, they realized a lot of the data was about human beings, not just about ships across the Indian Ocean and so on. And so you could offer new services based on that. And so the recommendation system was kind of the simplest thing you could think of. I got one client here who's bought some things. Here's a similar client who's bought some similar things. Why don't I recommend some of the purchases from one to the other? Building that in a simple little way in the lab is easy, just like with test tubes. Building at the scale of hundreds of millions of people is really hard, and it's still hard to this day. In some recommendations, like books or movies, you'll get pretty good recommendations. In lots of others, like shirts or trips or whatever, you'll get terrible ones. It's still very, very hard because it starts to bring in the whole scope of human life and human interests. And that's what I'm saying is not existing yet. We don't know how to bring humans fully into our cybernetic systems. Okay, so now fast forward, now we're in this, what I would call the third generation of pattern recognition. So it's the neural nets, it's the deep learning, it's all this. So why are people so excited about it? And they didn't talk so much about the first two generations. There was never articles in the New York Times about the first two generations, even though those were billion-dollar industries, okay? There's articles in the New York Times suddenly. Well, because it's about data that looks like human capability, speech recognition and vision. And there's enough data that you can start to mimic how a human does. You're not doing it like a human does. You're not nearly as good as a human, but it starts to look like it's getting to human levels of accuracy. We're going to talk about accuracy later. Accuracy is a problem. But we're not mimicking humans, and we're not nearly as good as humans, certainly not in things like machine language translation, which it's just mimicking string-to-string matching, which is not how humans do when they translate from one language to another. We understand what's being said, what's being talked about in the world, in the social sphere, idea sphere, and all that. We understand it, and then we say that in the other language. That's not string-to-string matching. So we're probably decades away from real natural language translation. That doesn't mean it's not a commodity, that you can't download it and fake it. I can walk around in China and I could talk into a device and Mandarin could come out because of this string matching thing. But that's not AI. All right, that's just that's a commodity, but it's extremely limited. So why are we talking about so much? Because it looks like we're mimicking humans, and it looks like suddenly AI is really happening. It's not. Okay, we don't know what intelligence is. The abstraction ability of humans to think deeply, abstractly about long time spans and so on. We have anything like that in computers. Okay, that doesn't mean computers aren't doing more than they used to do, and so on, and, et cetera. But it's still not a billion-dollar industry, this third generation. Not even close. Okay, surveillance technology is emerging, fine, but I don't see that as a billion-dollar technology. I'm sure it's good for humans necessarily. What I actually think is emerging is even more interesting is this fourth generation. It's the emergence of new markets. So don't think about the individual computers being smart and replacing a human. Think about a system like Uber, just to be very concrete and dumb it down. Uber in the city of San Francisco right now is a big decentralized and partly centralized system that is bringing cars to various places, pricing things so that when someone has a need here, there's a car ready to respond, and someone goes in that car and gets dropped off, and it was all priced. And the overall flow of the system is such that people move around the city much more rapidly than they used to. That's a system, and it's based on data, it's based on macroeconomic ideas, and it serves, tens of millions of people or whatever, some big numbers all around the world, right? That they designed that by hook or by crook, and they were kind of lucky and smart enough to kind of design something that kind of worked. But it doesn't work very well. They don't make any money. They lose lots of money, okay? But anyway, that's a concrete example of actually that's the overall system. That's the thing that should be intelligent. It's not the individual decision maker inside of a car, whether it's a computer or a human. It's the overall system that needs to be intelligent, okay? That's the level you need to think about. Now think about that not in the domain of transportation, but in the domain of commerce, of food, of entertainment, about medicine. Medicine is a planetary scale thing, right? If one person's treated over there and it works, that should immediately flow to everybody else's treatment the next day. It should all be kind of linked up, all right? Those are the kind of systems we're trying to think about building, and those are the business models you should have in mind. Is how do I build a service like that? And so I pick out Uber actually because in my mind, it's a success in the following sense. It linked producers and consumers. The producer is the person who has a car. The consumer is the person who needs a ride, all right? By linking them, a service happened and some payment went. I was willing to pay for that. It was worthy to me. The company takes 5% or whatever fee they take of that. They don't have to do any advertising. There's no click-through rate issues. There's no news feeds that are messing up the world. None of that, okay? Now, can you build business models like that in other domains? Why can't Google do that? Google didn't connect producers and consumers, really. They created an ad market to make money. Well, do they have to do that? Well, maybe, I don't know. But think about YouTube as actually possibly a connection between producer and consumer. Someone made that video over there, and someone wants to watch something like that. But if there's a real connection between them, so I'm going next week to Mumbai, first time in my life. I would love to go on the internet and say, hey, I'm going to Mumbai. And just like in a recommendation system, it'll know something about me. It knows my age, it knows what kind of things I'm interested in, it doesn't know everything about me. But I'm willing to give up a little privacy to that system because why? Because what's going to come back is somebody maybe living in Mumbai sort of recognizes that they're like me, they know people like me, and they can make a little video on the spot, or they can write a 2-page document that tells me all the cool things they do in Mumbai this week. And really, for me, all right? It's not a computer that did that. A computer will never know enough to do that, right? But a person could, and then I'm going to pay that person $100 or $50 or whatever. Totally reasonable. I don't want to pay YouTube that, but I'll pay the person. Person then makes some money, YouTube takes 5%. They don't do any advertising. They set up this relationship between producer and consumer. For me, that's way more healthy as a business model, and it actually can work. I believe that that's the right way to go. And now think about doing that for other domains. Okay, so I'm going to get to one later on music. Okay, so if that's where you think things are headed, then you've got to think a little bit more out of the box. It's not about downloading some piece of software. It's not going to get some DevOps guys going and blah, 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 you start running with a data set and all that. It's what's my overall system and how's that reconcile with a business model? What are the services I'm trying to tap into? And what are the producer-consumer relationships out there that I'm trying to feed off of? Okay, if you don't think through all that, I don't think you're going to be a success. If you think through all that, you have a chance of being a real success. All right, now on the other hand, there's all kinds of underlying engineering challenges here, and they aren't just known things. These are research problems. So in a big company like Amazon or Alibaba or DD or whatever, this is what the engineers work on. It's problems like this. Building markets, error control for decentralized decisions, cloud edge interactions, abstractions, provenance, et cetera, et cetera. None of those are solved. They're solved back in old domains like the banking system. You had to worry about provenance because you had to know where the dollars came from and all that, or you had to annotate it. In the do-know domain, where it's not about dollars, it's about medical care, so some piece of data is being used from the past to help me with my medical care today. That data may be out of date. It may be not appropriate for me. It may be the wrong machine or wrong people. I got to know all that stuff, and that's the provenance question. That's hard. We don't know how to do those kind of things. So anyway, I work on these things, and so a kind of more of a different kind of talk I give. I just kind of go through some emerging solutions, or at least attempts at solutions at problems like this, and they're mostly brand new stuff. They're not in any textbooks. All right. So I'll get a little bit to these issues in the talk, but really I want to go kind of back to this problem of what kind of systems do we have, and what can we hope for, and what has it related to business models. So just to kind of push on this a little bit, do we have intelligent systems on Earth? right? And so if you're like at Mars and you're looking down, you're trying to inspire yourself about some intelligent system on Earth to build Martian computers, what would you see down here that's worth imitating, right? And well, you know, those things, brains and minds, they're obviously intelligent, all right, but they're really hard to understand. You know, a brain, even a single neuron, even a single synapse is this sea of ions and proteins and voltages in 3 dimensions, and we don't have any idea, really, what it's doing, okay? The hope that we're going to understand that, or we have understood that, in 500 years, yeah, we're going to start to understand it. It's really going to be that amount of time. It's like the Greeks looking and think they're getting ready to go to the moon. They can conceive of it, but they don't really have any idea, okay? And I think the Martians would be smart enough to realize that, so they'd say, okay, we're not going to try to mimic human brains and minds. We may be roughly inspired by it, but that's not, we can't do that, right? But what else is intelligent down on Earth? What's working down on Earth that we could sort of use and bring into our computers and help us think, right? And so now you got to think a little out of the box. What else is intelligent on Earth? Well, markets. Markets are intelligent, okay? So markets do things like bring all the food you need into the city of San Francisco every day. It's a big system. It's decentralized. No one designed it really, but you got to tweak it. You got to regulate. You got to work with it. It's complicated, but it works. Every day, every city around the world has got food flowing into it, and it's roughly the right amount of food for every restaurant to have every dish it needs, and every household to have every food. Works at small scale for villages and cities. It's worked for 3,000 years. It moved humans from being in the trees and out on the prairies to being in cities. You know, markets are the biggest thing that ever happened for human beings. Now, they don't entirely work. There's failures. There's monopolies. There's all kinds of issues. That means is we, as smart engineers and scientists, got to think about it. And we use market ideas in our evolving ecosystems. We got new challenges going to come up, and we're going to have to bring that together with machine learning. Markets have mostly not been brought together with machine learning at all. When you design a market, you assume you know all the preferences, you assume you know the game theory little tables, and you design based on all those numbers being known. They're not known in the real world. So machine learning's got to supply those numbers, and it's got to be done at scale, not in like 2x2 tables. It's got to be done on 100,000 or 100 million by 100 million sorts of tables. Those are things that this emerging discipline needs to start to face. All right, so just to say this one more time, markets are decentralized algorithms. They do complex tasks, and they are intelligent by any definition of intelligence. It's reasonable in our era. They are adaptive, okay? They're robust, they're scalable. You don't have to do software updates. They kind of adjust on their own, and they have very long lifetimes. Our current systems do not have long lifetimes. If I build a deep learning network based on some data and I put it out there today, you think it's going to really work in 10 years? Not even remotely. Okay? Even if you keep adapting and adding little bits of data, will it still work? No, it's going to head off into something crazy. Okay, so markets aren't perfect. There's lots of research opportunities. So here's just some of the problems that I'm currently working on in my research career. Multi-way markets in which you've got to explore to learn your preferences. Large-scale multi-way markets in which each side of the market views the other side via a recommendation system. Okay? Recommendation systems allow me to focus on the things I care about, not all the possible billion products on Amazon. I look at a subset. What if in a two-way market, both sides are looking at subsets, and you do the matching in those subsets, and you do that across everybody? That starts to sound like an interesting new kind of market. And then so on and so forth. Okay. So now let's talk a little bit more about more towards machine learning issues. So I argued earlier on that machine learning was pattern recognition is kind of half of it. The other half is decision making. All right? But you know, some of my neural net friends might say, well, decision making is easy. I just build a big neural net and it's a perfect prediction engine. It has the best data in the world, better than any human had ever. And so its outputs must be trustable, right? So do a little thought experiment. Imagine you're going to your doctor's office tomorrow or next year or something, and the doctor measures all kinds of things about your body, includes your genome, and throws a 50,000 dimensional feature vector into a big neural net. And it's been trained on all the world's medical data, really, really the best we have. And its outputs are to be interpreted as probability of disease, given all the previous diseases that people have had. All right, so suppose you go in and some output is over 0.7, and if it's over 0.7, that's a sign that you're about to have a heart attack. All right, are you going to treat that as a decision and go have a heart operation, you know, to avoid that heart attack that's about ready to hit you? Okay, you go, no way, right? So first of all, you want an error bar. Okay, suppose your number is 0.0701, and 0.7 is the threshold that somebody set. All right, you're going to say, well, wait a minute, what's the error bar here? And what do you mean by an error bar? Is it an error bar because the data is a little bit out of date? What data did you use actually for me? Is that data from 10 years ago, or is it data from last year? Is it about data about people like me who have my diet and my genome? What if I were to change my diet? What if I were to run more? What if I were to do this? What if I get a second opinion? Those are what if experiments. That's not in the data. That's other data I could get. And maybe I'll even add a little data, or I'll change my data, okay? So when you're doing that kind of thinking, there's a whole loop around your learning system, and you're adding new data, you're changing, you're trying things out. That's what a real decision with consequences has to do. Okay, a lot of the systems people build don't have consequences. If there's a bunny in the image or not, if you make a mistake, who cares? All right, some advertiser's not happy. All right, but if you make a mistake on your heart operation, yeah, you care. But also if you make a mistake on transportation or in commerce or in entertainment, people can get hurt, right? So you have to care. Right now, when there's real-world decision with consequences, it's rarely just one decision. It's always a linked set of decisions in a network of some kind. That's what medical decisions really are about. And it's not just one decision for me. I'm making a whole bag of decisions today, and I want most of them to somehow be good. All right? Just if one decision is perfect and the rest are not, that may be not very good. Okay, and moreover, if we're making decisions as groups of us, there's going to be scarcity. We all can't go through that door at the same time. All right? We got to decide how to do things in some linked way so that we deal with that. All right, so let me start to get closer to business models. So recommendation systems have been and will be the source of many business models. All right, I can recommend things to you like books or movies or restaurants or whatever, and you will probably buy more of those. And it's a reasonable thing to do based on all the data you have to get people to do this. Okay, now does this actually really work? Well, not so good, and it's going to work less and less well if you try it in domains where there's scarcity. All right, so suppose you built a big recommendation system, you're recommending movies or books to someone. That's what Amazon has done so effectively. Well, there's going to be huge numbers of people using your system, and you could recommend the same book or movie to more than one person. You could recommend it to 100,000 people, the same movie. And that's going to happen. I'm sure that happens all the time at Amazon. That's not a problem because you can copy the bits and stream them. There's no scarcity. You're in the computer science world of no scarcity. Similarly with books, you can copy as many as you want nowadays. That's hard technology, but you can do it. But what if you take recommendation system as a commodity and you build a restaurant recommendation app that everyone downloads on their phone and it recommends restaurants, okay? Something like OpenTable, but really done right, okay? Now, is that going to work? Well, I know it's not going to work because I've seen it being tried in China where so what I would love is I'm going to, in fact, I'm going to Mumbai next week. I don't really know anything about the city. I may be by myself. It's 6 p.m. I'm hungry. I want to be able to push a button on my phone just like Uber and say, geolocate me and know some stuff about me. Not everything about me, not my browsing history, but know about, food I like. Certainly I like this kind of cuisine and I have this kind of price point and all. And broadcast that to the other side of the market. The other side of the market is all the restaurant owners near me. Now, they're all looking not just at me, but a whole bunch of other possible clients, and they kind of want to pick, hey, we like that kind, we want to support, so they'll make offers, all right? And maybe there's something on my phone, Bing, there's a 10% discount offer, and I see the restaurant, I see the food, I see the price, and I accept, all right? The system that provides that, it's going to be hard to build, but by linking us, it makes me then I wanted to go to that restaurant, I pick one of the seats, and they're not going to offer that seat to 100,000 people. The system cannot do that because it's a market. It's not just a recommendation system. Right? So they offer it to me, I accept it, a transaction happens, the system that provides that takes 5% cut. And if they do that at scale, they're going to make a ton of money. And they don't have to do any advertising. Okay, they don't build a free app that everybody uses and they advertise against. That business model, the old Google playbook, Facebook, is dead. You can still make money on it, but it's not going to help you or society. There's a better business model, connect producers and consumers. Right? After you've done that, in fact, you can do all kinds of other things. Markets are creative. If I've been going to certain restaurants a lot, what do they want besides just knowing about me? They want a loyalty program. You, as the app, can run that. And you can run that at scale for every one of the million merchants that are in your system. Every one of them would love to run a loyalty program, just like United Airlines, right? And then people are not going to move off of your app to the next new cool app because they have their points on your app. You've locked them in with data analysis, right? Because you provided a real service. Because if people leave the app, they lose their points. And people do not want to lose their points. I can assure you of that. All right? But anyway, markets are clever in this way. And to build scalable, large-scale data analysis markets, that's really worthwhile and interesting and challenging. Think about recommending streets to drivers. What's the fastest way to the airport? There's some street that's supposedly fastest. What if the app recommends that street to not just a few people, but everyone in the city starts using the app? It's a very popular app now. It'll recommend the same street to everybody. Bad idea. Now here's where Silicon Valley, I think, gets it wrong. Instead of realizing that you need to bring the humans into the loop, really, they think what they're going to do, they are so smart, they're going to figure out what we really want. They know our browsing history, right? They know everything about us. They're going to figure out which road we would really prefer, all right? And then they're going to decide who to send down which street. Or maybe they're going to figure out how much of a hurry I'm in right now. And they will figure it out on the app, and they'll just tell us what street to go down, and everything will be fixed, guarantee you. Because their AI is the world's best, right? That's ridiculous, right? I do not know in a given moment how much in a hurry I am, but if suddenly the app tells me, congestion, would you rather pay a little bit more and have a faster route today, or are you willing to save a little money for some future time? In some sense, maybe there's an avatar that helps me. A decision is made on my end that goes into the system, and now I go down a particular street reflecting my own current needs and desires, which I didn't even know about until I thought about it, okay? So build markets like that. Recommending stock purchases. So this, again, comes from being in China a little bit. People have some money for the first time in their life. Some grandmother wants to invest her $1,000. Somebody says, well, you can download an app to do that, and people do. There are apps that recommend stock purchases to you. If a very few people are using the app, no problem. If everyone in the country starts using it, suddenly it could recommend the same stock purchase. It could say everybody should buy 10-cent stock today. Everybody buys 10-cent stock, and the price shoots up, and you've destabilized the market. Okay? We can't do things like that. All right, so the alternative here is in some sense not that hard. Create markets. Use your machine learning not just to create a service, a platform, et cetera, et cetera. Use it to create a market. Think in that way. All right? So make sure that the producers and consumers are linked. So diners on one side, restaurants on the other, street segments on one side, drivers on the other, and so on. So this is not just classical microeconomics, game theory or whatever. It's all about recommendation systems and data analysis and humans and all their preferences and so on and so forth. By the way, I don't see a amount of time here. I have my thing. Are you taking care of that for me? All right, thank you. Okay, one more business model thing, and then we'll see how much time I have left for more technical material. So music, this is my favorite example. More people are listening to music than ever before by far. You just see people walking around with headphones on, right? And more people are making it than ever before. That's actually kind of surprising. And now here's what's really amazing, is that most songs being listened to right in this moment, like 95%, are songs that were written in the last 2 years. So all of us who are a little older think everyone's listening to the Beatles and Rolling Stones. Well, some people are, but no, not at all. And moreover, most songs being listened to were written by artists that none of you have ever heard of. And they were written in the last 2 years. Who are these people? Well, these are kids that are 16 years old who are pretty good on a laptop and made a really cool, hip-hop song, and everyone is listening to it, right? And that is the bulk of the so-called market, but it's not a market, because those kids, what are they doing? They're putting their song up on SoundCloud. Some service in Silicon Valley, like Spotify, is picking that song and streaming it to a bunch of people, and they get no money. They're not in a market. Occasionally, Spotify will offer a little bit of spare change to people, but it's not a sustainable real market at all. All right, does that mean there's something missing? Yeah, there's something easily fixable that's missing here, and the company that creates this is going to make a lot of money, it'll make a lot of people more happy, and it's going to prosper. Whether Spotify does this or not, I doubt it. They haven't done it yet. Whether Apple or Amazon does it, probably not. Who knows? But here's what it is. It's really simple. All you got to do is something like this. All right, there's data out there. Data means we can start thinking about economic value. What is the data? Well, it's the streaming data. It's that here's some kid wrote a song, it's on SoundCloud, and that got streamed to 10,000 people yesterday. Okay, that's data. All right? At the end of the week, you should assemble all that data with all of your engineers and make a dashboard available to every person who made some music, who had some songs on SoundCloud. On that dashboard is just a map of the United States, and they're going to see a little dot every time someone listened to one of their songs this past week. Okay? So if I'm a kid making music and I suddenly learn that in Dayton, Ohio, 5,000 people listened to my songs last week, suddenly I realize that I'm popular there. I had no idea, some word of mouth or whatever. And now I can show that data to venue owners, or probably the venue owners are already looking at the same dashboards. The venue owners see, wow, you're popular in our city. Come, we'll broadcast to all the people who've been listening to you, you're arriving, and you can give a show. All right, now little things like this really happen, but imagine doing this at scale like Uber did for transportation. All right, so the kid goes there, they give a show, they make $20,000. That's what you can make at small shows like this. They do that 3 times during the year, that's a salary. all right? They have a job suddenly, which they never had before, doing the thing they love, right? And now a market has been created. Whoever came to my show, I'm going to link to them. You know, I could broadcast other shows to them. I could give them backstage passes. I could offer to come play at your daughter's wedding for $10,000. Okay, you're going to be super excited. The latest, greatest person that you love their music is coming to your wedding. Imagine doing this. This is like 1 million people could have this job in the United States, easily. Okay? Now, Beyonce could do all this, but Beyonce doesn't want to do all this. Beyonce's got plenty of money, and she's not in the middle of a market. The record companies just propped her up. It's not even a monopoly. It's just this kind of fake thing where some really good artists are given hundreds of millions of dollars, and all the rest are giving zero. Okay? So create a company that does that. All right? Now, actually, in this case, you'll be behind a little bit because there's a company called United Masters that does this. It has 100,000 artists signed on. It seems to be taking off. I don't know. We'll see. But they have this kind of model where the artists are empowered to learn about what's out there, and then actually brands can start to learn about this, and eventually an advertising market can arise. That I'm Nike, I want to advertise based on the latest cool 16-year-old, not on Beyonce, because everyone's already paying her a lot of money. Okay? All right, so I hope you see that this is doable and it's really interesting. You create a market, you link, wherever data is flowing, you can think about, is there value associated with that data? If it's a song, no one's going to pay for that song. That's dead, I agree, all right? And the bits can be copied, there's no value there. But the fact there's a connection made, that's valuable. If you can pull that out and create the market based on that, you can start running with this. Now, is it just music? Heck no, think about art. Think about I have a new house. I'm building a wing in my house. I'd love to have some art on that wall, all right? I can go try to find something and pay a lot of money for some copy of an Andy Warhol thing, or I can broadcast that to the other side of the market, which is people who make art. They can look at my house and they can say, I could do something beautiful there and it look roughly like this, right? The company that provides that takes 5% and does all kinds of other cool things based on that with all that data. Right? So this is not new, really. I mean, people talk about things. This is the gig economy, if you will. It's kind of et cetera, et cetera. Things like this kind of proto-exist, but it's shocking to me how few companies have this as their business model. And the ones that do are just doing it in a kind of a very weak way, not really using serious machine learning and data and really trying to scale it and make it really viable. And so like I say, Uber does this, but they somehow have not yet made it viable yet, which is shocking because it's being used, right? It's really good, but somehow they didn't able to think it through really well enough. Okay, so I'm down to nearly 5 minutes. Let me just say this is what I work on now in my research career. So just give you one flavor of a kind of a research problem that one can work on as an academic or as a person in an industry. Here's one that we're with my students, Lydia and Horia. We started thinking about bandits and matching markets. So bandits is a core machine learning problem. You have K options, K choices. You don't know which one is best. You try every one of them a little bit. This is like hyperparameter optimization or model selection. So I tried that one. I see, well, that's pretty good, but I tried this. Oh, that's even better, and I keep trying. There's algorithms that do that. There's something called UCB that's a really good algorithm. And A/B testing is done with this. It's a thing. All right? Matching markets are a thing. The kidney market, the market of deciding which doctor goes to which hospital is a big matching market. Big success story in economics, Nobel Prizes and all. You would think that putting the two together would be a very natural thing to do. It hadn't been done. Okay, shocking. So let's talk a little bit about that. So here's a multi-armed bandit. Here's a person having to make a decision. If they choose option 1, they get a reward. If they choose option 2, they get a reward. And the rewards are different, and they want to find out which option gives me the highest rewards. Okay, now again, that's been analyzed to death. There's been tens of thousands of papers on it. It's used in industry, A/B tests, drug discovery, and so on and so forth. Right, but the real world is not just one person making one decision. That's just not what it is, as I alluded to earlier. It's always multiple people making multiple decisions. All right, so that starts to bring us into economics, and here's one of the core ideas in economics. We've got buyers and sellers. They have preferences. The buyer prefers seller number 1 to seller number 3 to seller number 2, and everybody's got their preferences, and then the sellers have got their preferences too. And then a matching algorithm like Gale Shapley runs and tries to match as best as possible. Not everyone will get exactly what they want, and the neural nets associated with each buyer are not going to be entirely happy, right? But that's how it works. The problem is with this is that no one knows their preferences, like for restaurants. And you can't give me, if I'm thinking of 10,000 restaurants in Shanghai or Mumbai, I don't know my preferences, and I'm not going to go through 10,000 of them and check and put numbers next to all of them. No way. So I've got to try them out and limited scale, and I've got to start to figure out my preferences. Okay, so if we put matching markets together with bandits, we start to get a little bit of the flavor of this. Okay, so we have to learn through exploration and exploitation what our preferences are in a two-way market context. So now we have competing markets. The bear and the human are both going to try to pick things. And here's what's going to happen. If the human picks arm 2 and the bear picks arm 2, arm 2 is going to have to choose between one of the two. It's not going to get both of them are not going to have the arm, the reward. All right? And the arm has a preference on us. It prefers bears to humans, it looks like. Okay? So it chooses, maybe stochastically, and the bear gets the reward and I get 0. All right? Now that I realize that's happening, I really was liking arm 2. It really looked great reward for me, but I see the bear is going for arm 2 and I'm not going to get it maybe. So I hedge my bets and start to explore the other arms more. All right? And so you can make mathematics out of that and have new algorithms, and we did that. Okay? So there's papers emerging here. But the main point is I hope you sort of see this is kind of a new way to think. It's just to make decisions and do learning, but in the context of a system that has scarcity kind of thought about as part of, in this case, a market idea. Okay. So let me skip some slides here. I'm going to skip this too. I want to go all the way past some slides on Nash equilibrium, and I want to say a little bit about this. All right, so I've been talking about decision making and multiple decisions and scarcity. I just want to talk about a little bit about making multiple decisions even without scarcity. Just one person or one institution or one firm making lots and lots of decisions. Okay, so here's kind of a picture of decision making in the simplest possible setting. I've got two states of reality, 0, 1. And I have a decision, which is 0, 1. And so the diagonals are good decisions. If it was 0, I said 0, that's good. If it was 1, I said 1, that's good. And the off diagonals are bad decisions. All right? We know how to build classifiers, neural nets or whatever, to do things like this. Okay? They're supposed to predict a 0, 1, they make an error or not. All right? The way people measure the errors here are now the issue I want to get into. Mostly this is not the way it should be done. So if reality is 1, and I say 1, that's good, and the fraction of times I do that's called the sensitivity. Okay? So it's a row-wise proportion. Okay? It's also called the recall of the power of the true positive rate. Similarly, if reality is 0, and I say 0, that's good, the fraction of times I do that is called the specificity. Everybody adds these things up or trades them off or whatever, or takes the total accuracy, which is a similar sort of number, and evaluates things based on that. Okay? All right? These are like conditional probabilities that are row-wise. All right, here's a different conditional probability. It says, if you made the decision 1, what fraction of those are good decisions? It's called the false discovery proportion, 1 minus that. Okay, so here's my last and important slide. Let's suppose you're in some industry and you're doing 10,000 A/B tests today. That's typical of Amazon or whatever. They're doing 10,000 A/B tests. All right, and suppose you're in a situation where the oracle, you know, the supreme being knows that 9,900 of them are actually null. So if I'm trying to change my website and I've changed a few pixels here, nothing would happen. It's not going to improve my website. I won't get more people. It's a bad idea. So let's call that a null. Right? In 100 cases, if I made some change, something would happen. I'd make a lot more money because it's a better website. And this is typical that most of the time, most of the changes you make in a mature industry are not going to have any effect. Only a few of them will have an effect. So I want to make the discoveries. So I run some fancy neural net or whatever on this data, and I built the neural net of all the best, best engineers' best data. So its type 1 error rate, the probability of saying they're making a discovery when you shouldn't is really small, 0.05. Right? So if I apply that to that data, of the 9,900 times I should say null, I make only 495 false discoveries. Pretty good. Less than, it's 0.05. Similarly, on the other side, I have a very good power, which is the number of times I should make a discovery. How often do I make a discovery? That's the power, right? Or the sensitivity. So that is 0.8. So of those 100 non-nulls, 80 of them, a very high fraction, I make the discovery when I should. So it's looking pretty good in both of those arms, right? But here's the problem. Your boss doesn't care about those arms. Your boss comes in and says at the end of the day, I gave you a lot of money, $1 million, to run 10,000 A/B tests today, all right? How many discoveries did you make today? Okay? You say, well, let's see, I made the Oracle knows 494 files. I don't know that. I just know I made 495 plus 80. That's the total number of discoveries I made. So I tell my boss I made 575 discoveries today. The boss says, great, let's implement those. Let's go charging ahead with those. Here's the problem, is that 495 of your 575 are actually false discoveries. You should not have made the decision. So a huge fraction, over 90% of your discoveries are false. Now, is that bad? Well, yeah, because they're going to spend a lot of money actually implementing this in practice, and a few months later, they're going to realize it didn't work, and you're going to lose your job. This happens all the time, all right? And when you talk about neural nets and accuracy, that's the problem. Your accuracy is not high, you raise your accuracy. It's nothing to do with the accuracy, folks. My accuracy was super high, 95% on both arms. But the thing I should care about, which is over my bag of decisions, how many of them are false, is terrible, all right? So if you're an engineer, I hope this kind of wakes you up a little bit. You got to think in a different way, all right? And your education needs to be expanded. And if you're a business kind of person, you got to realize that the context matters, and all around the decisions and how you build these systems really matters. So you got to bring in people who can think in new ways and start to think about these new emerging engineering systems before we even know what they really are and how to build them. So I'm going to finish there. I had a few slides there, which I'm going to skip, just kind of how to do this. We have algorithms to do this. So last slides. This is the area of pattern recognition, TensorFlow, PyTorch. Those are pattern recognition systems. They are not solving the whole problem. They're doing half of it at best. The other half is decision making. We have some ideas, but it's still hard work, and there's a lot to do when you talk about high-stake decisions and real-world decisions and so on. So it's the Wild West, and it's a fun period, but caution is needed, care is needed, less hype is needed, and so on. So in terms of the hype, I wrote an article where I was irritated about the hype, and so on the plane on the way to the East Coast, I wrote this thing called Artificial Intelligence, the Revolution That Happened Yet. If you haven't read that, please read it. It's not me bragging about my great achievements. It's me kind of trying to tell people that there's too much hype, and that's not just a bad thing. Here's a better way to think. And the second article there is a little bit more what I was talking about today. In fact, here's kind of the path forward, is to bring in at least a little bit of economics. Thank you very much.